This here is an example of Pascal's triangle.
We're going to be doing 5 problems and explaining how to do those.
I'm Colby.
And I'm Christian. Let's do it. Okay, our first problem is from page 755. It is similar to the problems in exercise 9.5. The problem is x plus y in parentheses squared. First, what you have to do is look at what the exponent is. You see the exponent is 2, and that tells you have to look at row 2 on Pascal's triangle, which will tell you which coefficients to use. The second row on Pascal's triangle tells you to use 1, 2, and 1. Since you have to expand this, you will have x's and y's that have exponents. The exponents of the x's will go down, while the exponents of the y's go up. Knowing this, you know the exponent of your first x is going to be 2, and your coefficient will be 1. The next coefficient will be 2, and the exponent of x will be 1, and you will start with y, with that exponent being 1. And finally, the next coefficient will be 1, and your y will have an exponent or 2, which means your answer is x squared plus 2xy plus y squared. Okay, our second problem is x plus y in parentheses raised to the power of 6. First, what you have to look at is the exponent. You see the exponent is 6, so that tells you have to look at row 6 on Pascal's triangle, which tells you which coefficients to use. The 6th row on the triangle tells you to use the coefficients of 1, 6, 15, 20, 15, 6, and 1. Since you have to expand this, you'll have x's and y's that have exponents. The exponents of the x's will go down, while the exponents of the y's go up. Knowing this, you know the exponent of your first x is going to be 6, and your coefficient will be 1. From there, you progress in the x's going up and the y's going down to get x to the 6th plus 6x to the 5th y plus 15x to the 4th y squared plus 20x cubed y cubed plus 15x squared y to the 4th plus 6x to the 5th plus y. Go.
Alright, my problem is number 3, x plus 1 to the 4th. And with using Pascal's triangle, you're going to expand the binomials. And so here's Pascal's triangle. Alright, and our problem has, it's raised to the power of 4. So when we go on the Pascal's triangle, this is row 1, 2, 3, and 4. So what you're going to do, as you go across the row, x goes up and y goes down. But with my problem, x plus 1 to the 4th, it doesn't have y, so you're just going to use x. And so the answer you would have would be, you take 1, x to the 4th, plus plus 4, x to the 3rd, plus 6, x to the 2nd, plus 4x, plus 1. Go. This is problem number 4, 1 take away 2x to the 3rd. So looking at Pascal's triangle, you go to the 3rd row, and your coefficients are 1, 3, 3, and 1. You're going to take those and use it for your work. And you're going to split up the x's and the y's. Why? Going right, the powers of x's go down, and the powers of y's go up. Coming left. Alright. Now, what you have is 1 times 1 to the 3rd plus 3 times 1 to the 2nd times negative 2x plus 3 times 1 times negative 2y squared plus 1 times negative 2x to the 3rd. And once you simplify that, you get 1 take away 6x plus 12x squared take away 8x cubed.
Okay, our 5th problem is 3x squared plus 4y in parentheses raised to the power of 4. Now you know that the thing is raised to the power of 4, you have to go down 4 on Pascal's triangle. 3, 4. That tells you the coefficients you'll be working with are 1, 4, 6, 4, 1. You have to take the coefficients and split up the x's and y's. The power of x's go down, while the powers of y go up. When you have the x's, you see it squared. So you're going to have to progress the rest of the way through and put in your coefficients, and you'll get this right here. And that simplified would be 81x to the 8th plus 432x to the 6th y plus 864x to the 4th y squared plus 768x squared y to the 3rd plus 256 y to the 4th.